let's talk about sequences. Okay, first thing in sequences, only thing you did sequence was this, right? Not allowed. This is like, you've been warned under video recording. If I ever see any kind of formula that you have ever learned, it's automatic 0. Okay, formula results. And 0 points. So you've been warned, okay? Don't even think that you can use the formula in this class and get away with it, okay? So now, because usually an SAT, I know you don't no longer take SAT, maybe SAT 2, right? That's still alive, right? They give this kind of questions a lot. Let's say this is N and this is AN, okay? Let's see if you can see this pattern. 17th term, oh no, 12th term is 17, 13th term is 14, and 14th term is 11. You see the pattern? Do you see what's going on? And then question is, what is 37th term? Good luck with your formulas, right? And this is not even my level of problem. This is just SAT 2. They always do this to you. So if you use a stupid formula, arithmetic series, how does that help you? Because you still don't know what A1 is. Do you see the problem with this? And then if you look at the solutions manual of that, like whatever the SAT prep book that you look at, you use the formula to figure out A1 and you use the formula to figure out the 37. Like, what, really? And then you still have that fear in the back of your head. Did I do this right? Did I mess up the index? You know what I'm saying? Forget it altogether. Do we know this is how you do? Pattern recognition is everything in math. Supposedly, you all allegedly have brain, right? That's how you got this far. Let's use it for once, right? Because all these athletic people, they get to use their body. Maybe it's time for us nerds to use our brain instead of dang formula that means nothing to you. See how easy this is. Have we seen the pattern so far? This is 17 minus 3, isn't it? It goes down by 3. Do we at least know that pattern? So this is arithmetic series, decreasing by amount of 3. So this one is 17 minus 3, right? The next one will be 17 minus 3, minus 3, minus 3. Wait, we have a little more efficient way of writing this now then, don't we? So instead of that, right? And this is negative 3 times 3. Oh, this is negative 3 times 1 then. And if you want to complete the pattern, this is 17 minus 3 times 0 now, isn't it? Now we quickly notice what is the difference between this thingy, 0, 1, 2, 3, and 12, 13, 14. They differ by 3, you get it? So now somebody please tell me what this thingy, that pattern should be 37s. 17 minus 3 and 37 minus 12. You get it? You see how easy that is, especially with a calculator? And punch the calculator, and this is negative 58. And we still don't know what that formula is. Okay, you know, I know you know, but delete it permanently from your hard drive space. Okay, that's a precious space that you have a limited amount of. You cannot clog it up and waste it with dumb formulas like this. Right? Now, we will still talk about, I guess we'll talk about it. I said just delete it. AN is equal to A1 plus your common difference D, in this case, negative 3, times N minus 1, right? But this only works if you have A1. And the reason this is N minus 1 is because if this were 1, then this would have been 0, 2, 2 minus 1, 1, 3, 3 minus, you know what I'm saying? Just because it's starting at A1, that's why this is N minus 1. While now we are starting at 12, so this is n minus 12. You see how this way is so much better? The reason I emphasize this a lot is because typically in this chapter, we start the index not from 1, but from 0. Those of you taking Comp Sci, you know that different programs do different indexing, right? Many programs start with a 0. Some programs start with 1, and you have to know, you, the programmer, needs to know which is which, right? I mean, you can rewrite it and do the same thing, but still. So many times, I mean, it's like half and half. Like 60% of our problems will start from 0, 40% will start from 1. And then I have known to put this question on the test that starts at -2, just to punish those who memorize the formula. I mean, you get 0 anyway, but it's like to see the panic in your eyes. So forget the formula, it ain't gonna work. Number 2, even if you manage to figure it out, you still get 0, okay? Use your brain, you have one. Okay, let's talk about different series now. Say we have a n and b n now. Say we have 57th term, and we have 64. And then we have 58th term, we have 32. And we have 59th term and 16. Oh, guess what? 60th term at b. You see what's going on already, right? Geometric series. Dividing by multiplying 1/2. Okay, and then let's see, which one should we find? 70th term. Okay, let's do this one. So this one is then 64 times 1/2, isn't it? And this one is the previous one, 32, and this is already 32 times 1/2 again. And this must have been 64 1/2. You see how easy this is? And if you want to, for the sake of completing the pattern, it's this. So this thingy should be 64 times 1/2. Did I write 1/3 here? Oh my God. 1/2 to what power is the only thing, and that thingy comes from here. This exponent and that index differ by 57. You know what I'm saying? You know what I'm saying. So we put 70 minus 57, and that's it. And you just punch the calculator, whatever the hell that is. You get it? You get it? So if you want to talk about the formula, which you're not even allowed to use, your AN is equal to whatever that thingy, which they call it A1, but there's no reason that this thing starts with A1. You know what I'm saying? 57, and then common ratio R, and 2, n minus whatever this thingy is, in this case 1. You know what I'm saying? But there's no reason for us to memorize this formula, because I'm going to start this thing at whatever the hell, anything but 1, basically. Right? Any questions? No? All good? Okay, then shall we talk about some series? Let's talk about geometric, easy ones, geometric series, and the second one that looks, well, maybe you've seen it, and maybe you haven't seen it. Okay. Oh, have you done this before last year, infinite series? Goes all the way down to infinity? Well, you've done it like this, right? No, hell no. Okay, no, not allowed. How many minutes do I have left? Because there's a story to go with this, and
about 5.
10 minutes.
10 minutes. Okay. I'm gonna have to cut the story quick. If you are using this series, this is our problem. I'm gonna give you this example. What does that add up to? Well, the formula says first term over 1 minus, what is it? 2, right? Common ratio is 2. So this whole thing adds up to -1. You see the problem with this? Do you or do you not see the problem? Okay, let me show you where these things come from, okay? I'm gonna call this thing S. And then I'm gonna have another S. The other S is this, let's say 1 plus 1/2. Let's start with the 1/2. 1/2 plus 1/4 plus 1/8 plus dot 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 dot. The formula works for this one, formula does not work for the first one, okay? This is where the dang formula comes from. The technique of adding this geometric series, some people actually allege, is you multiply both sides by common ratio. So this becomes 2, 4, 8, and 16. And you multiply this by 1/2 now. Oops. Okay, and this is 1/4, 1/8 plus 1/16 and plus da, da, da. Okay? Then we subtract vertically. And let's see what we got. Let's do this one first. S minus half of S is S, right? You know, for the formula's sake, I'm gonna write it like that. Half of S, right? And this cancels that one, this cancels that one, this cancels that one, da 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 da, then you cancel forever. So S is equal to 1/2, your first term, A1, divided by 1 minus R. You get it? That's where the formula came from. Actually, no, I'm gonna derive the formula. But this is like equivalent of using that dumb formula without knowing what you're doing. Something's uneasy about this, right? You see like something's missing? It's not complete. What about that last term? There will be a leftover right there, right? Okay, what about this one? You subtract it, so we have 1 minus 2, common factor S. This cancels that one, this cancels that one, they cancel forever, so we have 1. So your S is equal to A1 over 1 minus R. Do you believe it? Of course not, right? Ooh. So we have to remedy this somehow, right? Okay, that's what this thing is about, okay? So I'm gonna do it the correct way now. And this concept is very important. This is huge in real mathematics, okay? I'm gonna call it as N. We're going to terminate it. And Sn looks like this. A1 plus A1R plus A1R squared plus dot 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 plus A1R to the n minus 1. Y'all with me why this is n minus 1? And how many terms are there? There are n terms there. You get it? Basically, I'm doing exactly the same thing here, but not the flawed way, the correct way. You cannot, and that you see something's wrong with that. There's that last term here, right? When there are infinitely many terms, you cannot just subtract infinities around like that. I told you already, infinity minus infinity can turn out to be anything. And this is, in fact, infinity minus infinity, isn't it? Right? Those same rules don't apply because infinity is not a number. You cannot subtract it. So we have to terminate it. This one is a finite number. Good? Then, this is a technique. We multiply both sides by common ratio like I did here. 2 and here 1/2. Good? And then let's see, observe what happens. This is A1R. This is A1R squared. A1R cubed plus dot dot dot, and we have a terminating term, and this is good. Then we subtract. Okay, so this is 1 minus r, common factor, Sn, not too much algebra, right? And this one cancels that one, this one cancels that one, this one cancels whatever's here, and whatever's here cancels that one. There's that last one. Ah, so much more satisfying now, isn't it? So what we have is a1 minus a1 r to the nth power. So far with me? Okay, this thingy I can factor, so a1, and this should look familiar to you as well, and I'm going to divide both sides by 1 minus r. Oh, that formula, does it look familiar to you? That is what my Sn is. Sum of the geometric series formula. This is where it comes from. You get it? Oh, I used n here. Sn, maybe n is okay. I used n is our index and I used n here. Okay. Let's satisfy anal mathematicians. We cannot use the same index, so we'll change that to k. Just to satisfy them, okay? I mean, it's like for our purpose, it's the same thing. But I just don't feel easy about using the same term. Still with me? So when we say infinite sum s, this infinity sign up there, what does that mean? We cannot really add anything to the infinity. But do you remember improper integral, when you have integral and then infinity sign, and then we have to change that to limit as b approaching infinity of that thingy? Yeah, it's exactly the same concept. So what we mean by infinite sum is not really infinitely many terms. We cannot add infinitely many terms. It is, so your infinite sum s, and this is s, is limit of sk where k approaches infinity. You get it? So if you take a limit of this thingy, a1, 1 minus r to the k over 1 minus r. Now, will it die or will it converge is the question, isn't it? It all depends. It all depends whether that thing dies or not. Right? If that thing dies, then this gives you your formula back. If this thing doesn't die, then we have infinity. So what is the case? If you take some number to the infinite amount of power, when does it die and when does it not die? This is not a misspelling, it's if and only if. This is the condition now, isn't it? If the absolute value of that number is less than 1, such as half, which is this case, this is half, then it converges and it works. If it's more than 1, then it's not going to work. And even if it's equal to 1, we already have a problem, denominator becoming 0. You know what I'm saying? So if this thingy is greater than or equal to 1, then this series is divergent. So if those of you who memorize this formula, you're only knowing the half of it, and you've been missing the other half all this time. This is why formula is bad, okay? It's the technique that matters. Okay, how many minutes do we have left? Oh, come on, people.
One.
Okay, when it's time, you guys can quietly go. I like to finish this example. Okay, let's just think about this. We'll just make it sk again. And sk is 1 over n, and then n from 1 to infinity, or up to k now, right? Partial sum. And then this thingy, right? Well, can we do a partial fraction? Is it this? Can you do easy partial fraction by looking at it like that? Up, minus, yeah. Okay, think about it. Don't have a time to do this for you. So this is my sk. Okay, Sn can be broken up And then I like to write that SK out. SK is 1 over 1. I'm going to write it. 1 over 1 minus 1 over 2 is the first term, plus 1 over 2 minus 1 over 3 is the second term, plus 1 over 3 minus, you see what's going on? Dot, 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 and 1 over k minus 1 over k minus 1 is the last term. And then as you can see, this thing cancels this one, this cancels this, cancels whatever's here, and whatever's here cancels that one. So only thing we have is 1 minus 1 over k minus 1, eh? How about that? K plus 1. Good. And then guess what my infinite sum S is? It's the limit of SK. SK approaching infinity. And that is limit of, and you only need to write one of the two. But I'm just trying to drive a point here. And this one will always die and give you 1. Name of this thing is called the collapsing series. I bet you haven't seen this kind before, right? You see, the technique is what matters. There's no formula. Somebody can figure out the formula, but that's a pretty complicated formula. Who needs a formula if you can do this faster than the formula can? You get it? So formulas are absolutely forbidden from now on. I mean, there are only few handful of formulas that I want you to know, and I will tell you what that is, and I try to prove it for you too, because it's too much complication to repeat the process. But these easy formulas are not allowed whatsoever. So I don't care what the grading guideline on AP Classroom says. Even if they do it with a formula, you're not allowed to. You've been warned on the recording. It's absolute 0. Don't ask me about it. Okay? It's bad for you. Okay? Okay. Any questions? Yeah.
Okay, yeah, so since we can't use formulas, for like 8.1 and stuff, do we just write like the 64 times 1/2, 64 1/2 squared? Like what work do we write? Like do we like since we can't do formula?
Here.
Okay, so the ones in red.
This is simple enough, right? You only need like 3 terms and the last term and bang. I mean, I'm not gonna insult your intelligence like this and putting this thingy on the test. Like, come on, this is like SAT tip, right? This is not even worthy of multiple choice. It's convenient to know, right?
And then for the geometric series, is it like the sums, or I mean the differences, or
what do you mean?
How you were like, oh yeah, above that. Yeah, are we just doing the black one?
Yeah, you do this.
Okay.
You call it SK or SM or S whatever, terminate it, and then you subtract using exactly this technique, and then that will always give you first and the last one. And then divide. And these are actual numbers, like in this case, -1, in this case, half, right?
Mm-hmm.
And then take a limit, and then that gets you the answer every single time. And some of the collapsing series, I've seen this before. I'm not sure if I have it in the homework, but like first 2 survives and last 2 survives.
Okay.
Right? It's always matching. If it's first 3 in the first front, then it's going to be last 3 in the back. So that has happened before.